Welcome to Unit 2, Lesson 20, Writing and Solving Inequalities in One Variable. In today's lesson, we're going to solve problems by writing and solving inequalities in one variable. We have two learning targets today. The first is that you can analyze the structure of an inequality in one variable to help determine if the solution is greater or less than the solution to the related equation. And your second learning target is that you can write and solve inequalities to answer questions about a situation. So as you take notes, these are the two things you want to take notes about or ask questions about if you do not understand them by the end of the lesson. Our warm-up today is 20.1, Dinner for Drama Club. It says Kieran is getting dinner for his drama club on the evening of their final rehearsal. The budget for dinner is $60. Kieran plans to buy some prepared dishes from a supermarket. The prepared dishes are sold by the pound at $5.29 a pound. He also plans to buy 2 large bottles of sparkling water at $2.49 each. Number 1, represent the constraints in the situation mathematically. If you use variables, specify what each one means. So anytime we have a word problem and we're trying to turn it into an inequality, we're going to go line by line and take the information as it's given to us. If there are pieces of information that we need, yet we don't have, that's where we use variables. So as we go through this, the first thing we're going to notice is the budget. And the budget is $60. Anytime you see the word budget, that is your maximum threshold. You can spend less than your budget. You can spend exactly your budget. You just cannot spend more than your budget. So we already know this is going to be less than or equal to 60. Now we see that the dishes are $5.29 a pound, but we don't know how many pounds. So our first variable will be x, and that will be pounds of food. And if it's $5.29 each, then we would say 5.29x. Next, we know that he's going to buy 2 large bottles of sparkling water at $2.49 each. We know both of those numbers, so when we write it, we'll use numbers. So that would be 2 times $2.49 each. So this is going to be the price of my food plus the price of my drinks, and it must be less than or equal to the budget, which is $60. So now we can do the multiplication. 2 times $2.49 is $4.98. Next thing we're going to do is subtract the price of the drinks from both sides. So minus $4.98 from the left and minus $4.98 from the right. And this is going to give us $5.29 per pound of food must be less than or equal to $55.02. Now I need to divide both sides by the $5.29 per pound. And we find out that the pounds of food must be less than or equal to approximately 10.4. So we could buy exactly 10.4 pounds of food, or we could buy less than 10.4 pounds of food. We just can't buy more. Now they want to know how many pounds of prepared dishes can Karen buy. So that's what we found on this previous problem. They wanted us in number one to just represent it, and that was our inequality we wrote here. And then number two wanted us to solve it, which I already went ahead and did. And we found out that it would be 10.4 pounds of food or less. So our next activity is going to be 20.2, gasoline in the tank. It says Han is about to mow some lawns in his neighborhood. His lawnmower has a 5-gallon fuel tank, but Han is not sure how much gasoline is in the tank. He knows, however, that the lawnmower uses 0.4 gallons of gasoline per hour of mowing. What are all the possible values of X, the number of hours Han can mow without refilling the lawnmower? Write one or more inequalities to represent your response. Be prepared to explain or show your reasoning. So we know a couple of things from this. We know that if this lawnmower were completely full, there would be 5 gallons in it. And we know that if it were completely empty, it would have 0 gallons in it. And we know that it's going to use 0.4 gallons per hour. So now we need to figure out how to use all of this. So they tell us that X is going to be the number of hours Han can mow. So if it were empty, that would be 0 gallons divided by 0.4 hours, and our hours would be greater than or equal to that because it can't be any less than empty. If it were full, then that would be 5 gallons divided by 0.4 gallons per hour, and our value would need to be less than that or equal to it because we couldn't mow any longer than if it was completely full. So we could rewrite this to say empty is 0 divided by 0.4, and that is less than or equal to X, which is our hours of mowing, which is less than or equal to it being full. And if we go ahead and do the math, 0 divided by anything is 0. And 5 divided by 0.4 is 12.5. So we could mow anywhere from 0 hours if the lawnmower is empty, up to 12.5 hours if the mower is completely full, and our number of hours is somewhere in between there. So this is how we would write the inequality that would represent that situation. So our next activity is 20.3, different ways of solving. This one states, Andre and Priya used different strategies to solve the following inequality, but reached the same solution. Make sense of each strategy until you can explain what each student has done. So we see that they both worked the problem until they get 3 equals x. At this point, they both know where to put the point on their graph, but they don't know yet which direction to draw the arrow. So Andre decides to test a number on one side of the point or the other, because if it makes it true, then that's the direction he draws the line. If it makes it false, he draws the line in the opposite direction. So when he tests out 4, he gets 19 is less than 14. And that is not true. So because 4 makes this inequality not true, every number on that side of the point would make this inequality not true. Therefore, Andre knows that when he puts the point at 3, he's going to draw the number on the number line to the left, because those numbers will make the inequality true. Priya, on the other hand, uses logic. She gets to this point right here where she sees that 4x plus 3 equals 18 minus x. And she realizes that if she picks a negative number for x, when she plugs that negative number into the left side, sometimes it will be a positive number and sometimes it will be a negative number. But if she plugs that same negative number into the right side, then subtracting a negative is actually addition. And if you're adding something to 18, you'll always have a positive number. Therefore, she knows that negative numbers will always make the right side greater than the left side, which is what we're looking for. So she knows that once she puts her point at 3 on the number line, she's going to draw the line to the left because that's the side that has negative numbers on it. Both methods are correct. It just depends on which method makes more sense to you. So now they give us 4 inequalities, and they want us to use one of these methods in order to solve. So they want you to try out Andre's method and Priya's method and see which one you prefer. So if I use this first one, 1 over 5 p is greater than negative 10, I know that I can get rid of a fraction by multiplying both sides by the denominator. So I'm going to multiply the left by 5, and I'm going to multiply the right by 5. Now I have p is greater than negative 50. So now I know what my value needs to be. Another way to do that is to first change this into an inequality or an equation. So 1/5 p equals negative 10. Multiply both sides by 5, and p equals negative 50. That tells me where to put my dot on the number line. But it doesn't tell me which direction. Looking here, I see that I have greater than only, so I know I'm going to draw a hollow dot at negative 50. And then I know that I'm going to draw p being greater than negative 50, so it goes to the right. So to me, that is the easiest method. Now let's try some of the others. So for B, let's try Andre's method. We're going to begin by rewriting this as an equation. I see that both sides are being multiplied by 4, so I can divide both sides by 4. That's going to leave me x plus 7 equals 2x plus 8. I prefer to work with positive x's, so I'm going to subtract x from both sides, which then means I need to subtract 8 from both sides. This gives me -1 equals x, so I know where to put my dot on my number line. I'm going to put it at -1. My symbol is less than or equal to. Because it has or equal to, I'm going to make a solid dot at -1. Now I need to know which direction to draw it. And Andre's method is testing a number on one side of that point or the other. So I'm going to choose 0. So if I have 4 times 0 plus 7 is less than or equal to 4 times 2 times 0 plus 8. Anything plus 0 is itself, so this becomes 4 times 7. 2 times 0 is 0. 0 plus 8 is 8. 4 times 7 is 28. 4 times 8 is 32. 28 is less than 32. Therefore, I draw my line in the direction of 0. And that would be Andre's method. So I do like Andre's method. If Andre's method makes sense to you, then make sure you use Andre's method on the tests. Now let's try C. We have -9n. We'll rewrite this as an equation. Divide both sides by -9 so that you get n by itself. And we find out that n equals -4. So we know where we're going to put the dot on our number line. We only have less than, not or equal to, so we are going to center this at -4 with a hollow circle. So Priya's strategy is using logic, and this problem sets up well with logic. If I have a -9, then if I put a positive number in here, a negative times a positive will always be negative. And a negative will always be less than positive 36. So if I know that all positive numbers are going to make this true, then I know I would draw my line to the right because that is the direction that I will eventually have positive numbers in. So when a problem is set up like this, Priya's strategy also works well. So if Andre's method makes more sense to you, then use Andre's method. If Priya's method makes more sense to you, then use Priya's method. But either way is correct. Now we'll do one last example on this slide. We have c divided by 3 is less than -2 times c minus 7. So the first thing we're going to do is set this up as an equation. Again, I can get rid of a fraction by multiplying by the denominator. So I'm going to multiply the left by 3, and I'm going to multiply the right by 3. So now I have c equals -2 times 3 is -6 times c minus 7. Next, I'm going to distribute the -6 into the parentheses. Negative times a positive is a negative. 6 times c is 6c. Negative times a negative is a positive. 6 times 7 is 42. Now I'm going to add 6c to both sides, and that gives me 7c equals 42. And now I can divide both sides by 7, and I get c equals 6. So I know that on my number line, I'm going to put my circle or my point at 6. My inequality symbol is only less than. That means it's going to be a hollow circle. Now I need to know which direction to draw my line. So I am going to substitute 0 into the original inequality and see if it makes it true. So 0 divided by 3 would need to be less than -2 times 0 minus 7. 0 divided by anything is 0. 0 minus 7 is -7. Negative times a negative is a positive, and 2 times 7 is 14. 0 is less than 14, so if 0 makes it true, then every number to the left of the point makes it true. So this is how we can solve. You can use Andre's method, you can use Priya's method, whichever method makes more sense to you. Use the method that makes sense to you. Our next activity is 20.4, matching inequalities and solutions. They want us to match each inequality to a graph that represents its solutions. So we can see that we have some with hollow circles such as A, D, or E, and we have some with solid circles such as B, C, and F. And the difference is going to be whether this symbol is equal to or not equal to. If it's or equal to, then we're going to be using one of the solid graphs. And if it is not or equal to, then we're going to be using one of the hollow graphs. So as we look, I have 6x is less than or equal to 3x. So if I divide both sides by 3, then I'm going to have 2x is less than or equal to x. So I could have 0, because then 0 is equal to 0, or I could have any negative numbers, because a negative times a positive is negative, and double that negative number is going to be less than that negative number by itself. So we want to start at 0, and we want it to be a solid. So 1 matches with F. Now we can look at the next one. I have 1/4 x is only greater than, so I'm going to be using one of my hollow circles. And it's greater than -1/2. So if I want to get rid of these fractions, I'm going to multiply by the bigger denominator. So I'm going to multiply the left side by 4, and I'm going to multiply the right side by 4. And now this becomes x is greater than, 2 goes into 2 once, 2 goes into 4 2, -1 times 2 is -2. So I need a hollow circle at -2, and then I need any numbers larger than that. So that matches E. Next, we have 5x plus 4 is greater than or equal to 7x. So because it says or equal to, this is going to be a solid circle. So it could be B, it could be C. What I'm going to do is subtract 5x from both sides, and that gives me 4 is greater than or equal to 2x. Now I'm going to divide both sides by 2, and I find out that 2 is greater than or equal to x. So both of these have solid dots at 2, but now we want 2 to be bigger than our x. That means we want all the numbers to the left. We want all the smaller values. So that means number 3 is going to match up with B. Now I've used 2 out of the 3 that have or equal to. There's only one more, which is number 6. So that must match up with C because it's the only other one that has a solid dot. Now we can look at this problem here for number 4. First thing I'm going to do is distribute this -4 into the parentheses. Negative times a positive is a negative. 4 times x is 4x. Negative times a negative is a positive. 4 times 1 is 4. Now I'm going to add 4x to both sides. That gives me 12x minus 2 is less than 4. I'm going to add 2 to both sides. And I have 12x is less than 6. And now I'm going to divide both sides by 12. And I get x is less than 1/2. So now I need a hollow circle at positive 1/2. So if we want x is less than 1/2, we see our hollow circle at 1/2. We see our line going to the left where numbers are smaller. So this one must be D. And now there's only one left, and that is A. We see a hollow circle. We see a greater than only, so that does match up. So this is how we would match the inequalities to the graphs that represent them. Our lesson synthesis, writing and solving inequalities in one variable, says we can usually represent the constraints in a situation with a single inequality. The only way to check the solutions to an inequality is to see if they make sense in a situation. The only way to find the solutions to an inequality in one variable is by testing different values for the variable and seeing which ones work. To express the solutions to an inequality in one variable, we always use the same inequality symbol as the original inequality. Our cooldown today is 20.5. How many hours of work? It says Lynn's job pays $8.25 an hour plus $10 of transportation allowance each week. She has to work at least 5 hours a week to keep the job and can earn up to $175 per week, including allowance. Represent this situation mathematically. If you use variables, specify what each one means. So, Lynn's job is $8.25 an hour plus $10 of transportation. So I'm going to let X be the hours of work. So that can be $8.25 per hour plus $10 of transportation, and she can earn up to $175 per week, including the allowance. So she could earn $175. She can earn less than $175. She just can't earn more than $175. So that would be less than or equal to 175. And it says she has to work at least 5 hours a week to keep the job. So X must be more than 5 hours or exactly 5 hours. So these two inequalities would represent the situation correctly. How many hours per week can she work? So if we use the first inequality that I had, if we wanted to know the maximum that she could work, then we set this equal to $175. This is the most amount of money that she can earn, so it will be the most amount of hours that she can work. We want X by itself, so we're going to subtract 10 from both sides. We have 825X equals 165. We want X by itself, so we're going to divide both sides by 825. And if we divide 165 by $8.25, we're going to get 20 hours. So the most hours that she can work is 20. So we could say 5 hours is the minimum. That is less than or equal to the amount of hours that she works, which is less than or equal to 20 hours. She can work a minimum of 5, anywhere up to a maximum of 20 hours. So if you go back to today's learning targets, if you are comfortable analyzing the structure of an inequality in one variable to help determine if the solution is greater or less than the solution of the related equation, then you are ready for the next lesson. If you can write and solve inequalities to answer questions about a situation, then you are also ready for the next lesson. If you have questions about either of these, please reach out to me so that I can clarify these before our next test. Our next test will be Thursday, November 30th.